Wasabi, you guys. We are going to continue on with the AI integration bee. We're going to see which free model AI is the best speed integrator. Well, at this point, it's mostly just integrating, not really speed, but pretty much we are left with 3 AIs. We have the Google, the Gemini 1.5 Pro, the DeepSeek with the DeepThink, and the Math AI, the Deep AI. Okay? So we are just pretty much continuing on the regular round integrals. So let's get to these regular round integrals, see if these AIs can solve them. Alright, for question 1, we have the integral. Not too bad. I'm a little surprised it used beta function. Wow. It utilizes beta function, but it's okay because it got the right answer, pi over 8. How about DeepSeek? So DeepSeek also got the correct answer. Holy hell, it also uses gamma and beta function. How about Deep AI? Pi over 4. Dang. Close. Very close. But I think it missed. It brought the 2 out of nowhere. Very close, but not quite. Alright, for the second integral, we have the absolute value, the integral of this function pretty much, this long function from -5 to 5. It's close. I don't know why it just ignored everything else. But close, but this is actually incorrect. It is not 25. What about this one? Is still ongoing, but the correct answer should be 29. It got 40. That is also incorrect. Let me recalculate. Oh no. Come on, DeepSeek. Oh! Oh, we got it! Oh, 29. Nice. Wow. By casework. That is brutal. It did it by casework. Wow. Oh, and it took advantage of the symmetry. Very nice. Alright, we are integrating another infinite function. And it seems like we have an answer 4 to the power of x to ln2. That's ln4. And that is correct. We have DeepSeek still thinking. It must think faster. No, I'm just kidding. No. But hopefully it does not trap itself somewhere. But for Deep AI, got 3. What? 2x over 3. That is incorrect, unfortunately. Ooh, Deep AI is having a struggle. Oh no. Oh no. Okay, good. I was like, I saw this, I'm like, oh no. It's missing an ln of 4. But nope, it got it. It got it. Very nice. Alright, our next integral is this monstrous trig sub integral. And holy hell, it was very quick. Google was very fast with this integral, surprisingly, and that is also a correct answer. Pi to the power of 4. On the other hand, DeepSeek is still struggling. Oh, and it got it. Pi to the power of 4. Let's see if it comes down with the correct answer, and it does. Come on, Deep AI is really struggling so far. Oh, and it finally got the right answer. Pi to the power of 4. Alright, this next integral is a tricky sum of inverses integral. And it seems to got the right answer. Wow. I don't know what it did though. It used I and J. I don't know. I was like, oof. I hope it didn't do something weird, but no, it got the right answer. On the other hand, oh no, where did that come from? No, take that away. Don't answer it with it. Oh no! Oh no! That's incorrect. Where did a pi square over 6 come from? Oh, it probably did it did what it DeepSeek did. Where was it? Somewhere here. Something like this. Yeah, that's a no-no. Alright, we have another King's rule. This is our integral. And of course it understood its formation and reformat it in a way where it gets the right answer. Nice. I don't know what it did here, but pretty much it was just pretty much King's rule. That's all you had to do. Oh god. 2i? I don't know why I use lowercase I. It kind of bothers me. Kind of bothers me a little bit, but we got the right answer. 0. Dang. That's unfortunate. Yeah, no, that is not correct. It is, the answer is 1/2. Alright, this one is indeed a tricky integral. It's a very sneaky Queen's rule, and it seems to... Ooh, pi over 2. Did it forget to divide by 2 when it did 2i? I think it did. I think it wasn't proper at x. Oh no. This is the correct answer. It is pi over 4. Yeah, 2i divided by 2, and you get pi over 4. Deep AI also got it right, pi over 4. That is correct. Alright, we have the sneaky, kind of a sneaky Gaussian integral, but it's not too bad. Of course, Google solved it very quickly. It is still working on it. For deep AI, 3 square root of pi over 2. Very nice. Taking a long time because it's using gamma. Oh, it just wants to make sure. Okay. Yep, that's correct. You got it. Alright, so obviously this is going to be an easy integral. Yeah, I know. I think they just kind of bashed it in. And just answer 4. As you can see, DeepSeek is really bashing it. That's it's an oof, and it got 4. It's correct, so I can't really deduct for that. And for deep AI, does it mess up its computational? No, it's not. Very good computational, so I guess it earns a point as well. Very easy integral for 3 of these AI. The quickest way is you can actually factor out the x cubed from this and move it in here, and then it's just a basic u substitution, and you should get the answer for it immediately. Okay? We have the following integral, very tricky, and I am surprised. Thank goodness it did not express it as an integer. It expressed it in this form. For DeepSeek, oh wow, also did not express it to overflow. You know, it also expresses it in terms of this, which is also correct as well. I'm pretty sure. Oh no, it got it right as well. Wow. Deep AI is really killing it now. Holy hell, it's definitely trying its best to handle these difficult integrals. Alright, we have the nasty integration by parts problem. 17.4 seconds. As you can see, it took it longer than usual. And oh no, 2 minus pi over 2 minus 2 ln of 2. Where did the extra 2 ln of 2 come from? Dang, so close! But it's not correct, unfortunately. Oh no. Oh no. It's getting into sums. That's no bueno. How about this one? Negative 5/4 minus pi over 2. That is incorrect. So both of these, this one's very close. I think, is it trying to avoid integration by parts? Or maybe it did, but it's just something... Oh god. It's using like Taylor series for arcsine, I think. Oh god. Straightforward. Oh no, it couldn't solve it? Dang. Computational numerical techniques are recommended. Dang. None of these. Google was so close, but something went wrong here. It's not. It's just ln of 2. The correct answer is 2 minus pi over 2 ln of 2. There is no 2. As you can see, it is just minus ln of 2, but the extra 2 came in out of nowhere. I don't know why, but it was so close. Alright, next integral. Oh my god, it's still going. Wow. 16.7 seconds. So, as you can see, these integrals are getting a little bit harder for these AI. And pi over root 2 over 8. Let's see. 8 is 2 times 4. 4 times 2. 4 root 2. Yeah, this is correct. That is the correct answer. Here it should have used, right here was the correct part. Unfortunately, it did not use area of a partial circle. That would have been faster. But it's okay. This is the form. This is what I have. So this is indeed the correct answer. Also got it right as well. So all and yes, representing a quarter of an area of a unit circle. Also pi over 4 root 2. So we have another difficult integral. Again, this one's 15 seconds. A little faster. But here, let's see, the final answer is 1. This is difficult to integrate further. Oh no. Dang. Well, that's unfortunate. No, it's not the correct answer. It's not 1. Here, come to conclusion. Equals to 1 as well. But it's not 1. It is not 1. The answer is not 1. I'm sorry. But that is incorrect. Let's see if DeepSeek can get it. The substitution. Oh no! None of them got it right. No, the correct answer is 1/2. The correct answer is 1/2. Yeah. Unfortunately, none of these AI got it right. But it's okay. It is a challenging integral. It's a very challenging integral. Like right here is where it's like, it gets very uncomfortable. But you just have to kind of maneuver it and be patient with it. So, alright, we gave it another infinite function. And of course, as always, Google gets the integral correct. That one's still solving for it. I'll let that do its thing. Here, notice its recursion. And, oh no. Execute integral. Pi over 2, x to the power of p over, what? Solve for radical, oh no. It is still trying to find a way to simplify it. You can do it. Don't mess up. Oh no. Where are these numbers coming from? Oh no. But I don't think it recognizes. Oh no, it cannot solve it. The integral is complex miracle. Oh, that's unfortunate. Well, only Google was able to solve it in like 8 seconds. So, unfortunately, we are tied with DeepSeek and Google AI. Deep AI is really struggling a little bit, but still trying to catch up. Alright, we have this integral here. And let's see, it got the right answer. Wow. Using the did it use inversion? No, it let u equal L of x. Okay. That is, I didn't see that coming. But okay. Oh, now I think about it. Yeah, no, you don't have to use inversion. I don't know what I was thinking about. But it did use symmetry. Yes, it did. So it took advantage of that, and it got the right answer. DeepSeek, on the other hand, oh, I think it got it. Yep, it got it. Let's see if it actually finalizes it. Oh no. Oh, okay. I was gonna say. Let's see, we got 2/3 ln cubed. Yep, Deep AI also got it right as well. So, very nice. All AIs got it. We see that Google was able to solve it. Yep, that is the correct answer. In most integration bees, we actually allow that. Like, you don't have to put plus c. We just care about the indefinite function. Some integration bees do care about the plus c, like my university, but it's no worries. Same with DeepSeek. Yeah, just reverse product rule. Yep, it recognizes this. Reverse product rule, very nice. That's also a point. Still tied with Google. Here, we see that we have square, what? Yielding, where does this come from? Yeah, I'm sorry, but this is incorrect. Unfortunately, Deep AI did not get it right. This seems to be an easy integral. So, yeah, I'm not surprised it got it right. So it's a point for Google. It's still struggling. Deep AI, 2. Dang, that is incorrect. It is not just 2. It should be 2 square root of e. Let's see if DeepSeek can do that. So far, Google's been, even though they're both integrating, Google really speed integrates. So I'm impressed with that. DeepSeek actually has to take its time and consider every method and see which is like the most correct. Oh no, unfortunately, I think DeepSeek is messing up its answers. Oh yeah, 8/3. That is incorrect. I want to make sure that the integral written was right. Yeah, it should be. But unfortunately, that is not correct. Ooh, it's still solving. Oh my god. 17 seconds. Ooh. Oh, that's brutal. Yeah, I'm sorry. I have to throw this at the AIs. But power substitution, like it did. Oh no, and then it did the same trap that I used to do. Oh god. Oh no. So close, but it's not 736. It should have been 1052. Oh, where did it go wrong? Okay. Well, it miscomputed somewhere, but this is equal to, oh well, it's not going to do the thing. Yeah. But this here is 1052 divided by 105 minus 3 pi. Okay, it's 1052. Ooh, but DeepSeek did. Wow. I like how it's like, it came back. Now they're both tied. First it was like Google got it, and then now DeepSeek got it. That is crazy. For Deep AI, did it get it? It did not. No. And I'm not surprised. This is scary. Okay. It's horrible. It's a horrible integral to speed bash. But surprisingly, only DeepSeek got it. Alright, we have an indefinite integral, and it seems like Google got it just right off the back. Just bam. Wait, that seems messy. Oh no. Oh no. Oh, that looks correct. Oh, now it's just checking its work. Differentiate again more carefully. Retrace my steps. Just let it take its time. Oh, it didn't match the original. Oh no. It's having that Wolfram Alpha issue type of thing, where it's like, oh, I don't believe it's the integral because the constant didn't match. But yeah, the constant's a constant. So, yep, and there it goes. It got the right answer. Deep AI, -2 square root. -2 square root of sine of x. But there's no inverse tangent. Dang. So it is unfortunately incorrect. Okay. Well, let's move on to our last regular round integral. Oh, it is going crazy. Holy hell. It is going crazy. Oh, it got it right. Yes, it is e minus 1. Oh, e? Oh, do not forget the 1. Oh, nice. Okay, so I think it's going to get it. E minus 1? You should get e minus 1. Yep, e minus 1. That is correct. Alright, Deep AI. The Deep AI got it? It got 1. Dang. Unfortunate. So, sadly, Deep AI, I'm afraid you are eliminated. I am sorry. Only DeepSeek and Google got it. Alright, here are the results. So unfortunately, Deep AI, I'm gonna be honest, I am very impressed with Deep AI. Probably the most impressive. I scrolled all the way. Holy hell. Yeah, this is Deep AI. Deep AI, Math AI. And wow. I am very impressed. The amount of loads it can, like it can go on forever, I believe. And yeah, I'm very impressed with Deep AI. But unfortunately, it couldn't keep up with Google and DeepSeek. So unfortunately, Deep AI You are our third place AI. I was gonna say third place person, but it's not a person. But I'm impressed with Deep AI, almost trying to catch up. So now we are left with Google and DeepSeek. They are both surprisingly tied with 15 points together. And so now let's just see if both of them are able to handle the semi-finals level integrals. So stay tuned for that in the next video. Okay? Thanks for watching, and I'll see you guys next time. See ya.